2.5 ordering fraction. I can order fractions.
Yeah, you walk up to the counter at McDonald's and you say, "Excuse me, I would like an order of fractions," right?
No.
Laugh. All right. Everybody, there are two really, really important definitions we use for a fraction. The first one is on the count of 3. 1, 2, 3.
Part of the whole.
Someone raise your hand and tell me where do fractions live. Where do all fractions live? I don't care what type of fraction they are. Where do they live, Gavin?
Between 0 and 1.
They live between 0 and 1 on a number line, right?
Yes.
They're bigger than nothing, which is 0, but they're smaller than 1, which is a whole. And fractions are part of a whole, right?
Yes.
You guys got that?
Yeah.
Okay. Like denominators. Can you have more than 2 like denominators?
No. Yeah.
Well, can I have 3 fractions with the exact same denominators?
Yes.
So can I have more than 2 like denominators?
Yes.
Yes, you can have as many as you want, as long as it's at least 2. What's another, I got it erased here. What's another name for like denominators? Oh, I'm sorry, it's over here. What's another name for like denominators, Ayub?
Common denominator.
Common denominators. They're the same exact thing. All right, number 2, getting like denominators. Can somebody quickly walk me through the process? How do we find common denominators? Only Don can do that? The rest, oh, Ayana can? Narjis, you can? So if I have a fraction like 1/5, and I have a fraction like 2/3, how do I find a common denominator? Because 5 and 3 are not common, are they? They're different. 5 and 3 are different. So Don, how would I find a common denominator for 1/5 and 2/3?
Find the least common multiple that they both go. You find a common multiple that they both go into, and then you times it by the number of that.
Don, that is a beautiful explanation. So 5 and 3 are not common, so we got to make them common. We got to find some commonality between them. And 5 and 3 both go into what number, Don? 15. So you said you can find the least common multiple, and then you change, say just find any multiple, right? It doesn't even matter if it's the least common multiple. The shortcut to doing this is just to take this denominator and multiply it by that denominator, right? So let me ask you this. If you have 1/2 and you have 2/4, give me a common multiple for 2 and 4. Everybody. 8, 4. I heard different answers, right? So 4 is the LCM, but if you multiply 2 and 4 together, what do you get? 8. Do either of those work?
Yes.
Yes, they do. Okay, so we find a common denominator, or a common multiple, then what do? Who can tell me what's next? What do we do next? Hello, Cece, I'm up here. I don't know why you're looking down there. Put your iPad down and look up here. What do we do next, Narjis? We multiply the what? Yeah, so if 15s are a common denominator, we multiply the denominator by whatever it is to get there, and then you multiply the numerator by the same thing. Yes or no?
Yes.
And then you do the same thing on the other side. And we're running out of time here, so I'm going to speed it up a bit. Quick question, number 5. Everyone look. 9 and 20. What's a common denominator for 9 and 20 on the count of 3? 1, 2, 3.
180.
Okay, that wasn't everybody. This video is not for me. I'm up here. 2 9s and 4 20ths. What is a common denominator for 9 and 20? Go!
180.
180. Good. Okay, number 6, another example that you can look at. And then the last part. We ordered fractions. Is there a difference between ordering fractions and comparing fractions?
No.
Well, a little tiny difference. When you order them, you put them in order. From least to greatest or greatest to least, whatever the directions tell you. But you always, you still are doing what? What are you still doing? What are you still doing, Ayub?
Multiplying.
No, you're not still multiplying. You'd be more specific than that.
Oh.
Look at this. We have 2 9s. We have 3 6. We have 3 4s. We have 2/3. Can you compare those?
No.
No, why can't you compare them? Cece, why can't you compare them?
Because they have unlike denominators.
Yes, they have unlike denominators. These are all different. So we have to make them so that they're all the same. And we've decided that 36 would do that, didn't we? Because 9 goes into 36, 6 goes into 36, 4 goes into 36, 3 goes into 36. Figure out how many times, multiply the numerators and the denominators by those numbers, and you're good to go. Yes or no?
Yes.
So if they have common denominators, can you compare them then?
Yes.
So if you have 8 over 36, 18 over 36, 27 over 36, 24 over 36, can you compare them?
Yes.
Yeah. This is the smallest. This is the next smallest. This is the next smallest. This is the smallest, and so on and so forth. Yes or no?
Yes.
We need more practice on this. No?
Yeah.
You're good? You got it? I'll give you the test right now. You want the test?
No.